Okay, so y equal to 4 divided by x. For x equal to, say, 1, y equal to 4 divided by 1, which is 4. So we know that the point x equal to 1, y equal to 4 is on that parabola. Say x equal to 2, y is 4 divided by 2, so 2. So x equal to y equal to, which is this point. We have x equal to 3, so 4 divided by 3, x equal to 4, we have 4 divided by 4, which is 1. So I think this is enough for us to graph. So it looks like this. So this is y equal to 4 divided by x. We only need that between 2 and 4. X equal to 2 and x equal to 4. Give us the two vertical lines. Then we also have the lines y equal to 0, which is the x-axis, which is this axis. So the region we will rotate about the x-axis is this region, and we revolve this region about the x-axis. Okay. So here's a graph of the region. Now, if we rotate this one about the x-axis, what look like is like this, and every point on this curve y equal to 4 divided by x give us a disc. So the solid would look like this. Okay. So when we rotate it, rotate about the x-axis, so our solid would be like this figure. So this is how our solid look like to the whole thing. Now we need to compute the volume of this solid. So we use the method of slicing. So if we slice this into pieces, so like imagine we chop it into small pieces, very thin, then each pieces look like a cylinder. For example, here. So one pieces could look like this. if we chop it thin enough. So if we have the segment 2, 4 and we do partition, then we cut it into small pieces. Each pieces has width delta x, and if delta x tends to 0, so if this piece or this cylinder is so thin, this one become dx. The volume of this cylinder, as we know, the volume of a cylinder is the area of the base times the height. So if we look the cylinder like this, so this is our cylinder. Then the height is delta x. The base is this disc. Height is delta x and base is a disc. So the volume is the area of the base times the height. The area of the base is a disc, so this has the center of the disc is say the point x. So this is the center of the disc, which is x between 2 and 4. The radius of the disc is this radius. So for example, in this case, 2x equal to 4, the radius is the length from the center here to the circle. So from the center to this circle or to x circle here, which is the value f of x. In our case, f of x is y equal to f of x. In our case, it is 4 divided by x. So the height is delta x, the base is a disc with center at x between 0 and 4. For each value of x, the distance from the curve, from center to the curve, which is the radius, the radius of x disc is f of x. In our case, it is 4 divided by x. The area of the base will be pi r square. So pi times the radius square, which is 4 divided by x square. So now we have, in this formula, we have pi times 4 divided by x squared, the height dx. That is the volume of one very thin slice. The volume of the whole solid of revolution is the sum of the volume of the small pieces, where delta x, the height of each pieces, tend to 0. This gives us dx here, and the sum, Riemann sum, become this, the integral. So our volume could be the integral pi 4 divided by x squared dx, where x between 0, where x between 2 and 4. So here's how we set up the interval. Which is 2, 4, 4 square 16 pi. So constant, we figure out that 1 divided by x square dx, right? 2 to 4 x minus, so in our case minus 2 dx. In the general cases is interval x to the n, where n is just a number. So 16 pi x to the minus 2 plus 1 divided by minus 2 plus 1 for x from 2 to 4. So minus 16 pi 1 divided by x from 2 to 4, minus 16 pi 1 divided by 4 minus 1 divided by 2. So minus 16 pi 4, we have 1 minus 2, 16 pi divided by 4, so 4 pi. So this is the cubic unit. This is the volume of the solid revolution we are trying to compute.